2, lesson 4, graphing functions. Okay. A, complete the table and graph the function for the given domain. Okay, we have the function f of x equal to 3x minus 2. For domain, negative 3, 1, and 5. Okay, the domain is elements. So we're probably going to graph some points. There's no lines, right? Complete the table. Okay, when d equal to negative 3. Okay, let's do negative 3. X equal to, so 3x minus 2. When x equal to 3, so this is going to be 3 times negative 3 and then minus 2. This is negative 9. So 3 times negative 3. 3 times 3 is 9. Positive times negative is negative. So negative 2 minus, negative 9 minus 2. So the final answer is negative 11. Negative 2 minus negative 9 add negative 2, that's negative 11. Okay, first one is done. Second one, when x equal to 1. So 3x minus 2, when x equal to 1, that means 3. 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 is 1. So here should be 1. Now last one, x equal to 5. So 3x minus 2. So this equal to 3 times x equal to 5. Replace x by 5. So 3 times 5 minus 2. So this is 15 minus 2. That's 13, right? So 13 here. Okay, negative 3, negative 1 on the graph. Negative 3. X value, negative 3. So 1, 2, 3. 1, 2, 3, right here. Negative 11, negative 11, right here. So the point is this. This is the point. Okay. Second point, 1, 1, x equal to 1, y also equal to 1. So x is 1, y is also 1 right here, right? Last one, 5, 13. So 5, x value is 5, the y value is 13. Oh, right here. Right here. This is, yeah, 13, 14, 15, yeah, right here. The point is right here. 5. Oops. Right here. The linear function. If we draw a line, it should look like this, right? Linear, a straight line. But the domain, they only give us 3 elements. So not continuous interval. So we just leave it as a point. Okay, number 2. Number 2. Domain is all the x value, right? 2, 3, 4. Or y equal to 2x plus, oh, no. Y plus 2x equal to 12. Oh, we need to figure out the y value. Okay, I'm going to get rid of the positive 2x. So the function, the equal sign separated the function into 2 sides. I'm going to get rid of the 2x, positive 2x. I'm going to move it to the other side, become a negative 2x. From positive 2x, if I move it to the other side, it's going to change to negative 2x. Or I'm going to get rid of 2x. 2x minus 2x. So positive 2x minus 2x, this part is gone, right? So y equal to 12 minus 2x. Either way, either method, you get the same result. Okay, now when x equal to 2, we need to figure out the y value. Okay, when x equal to 2, so y equal to 12 minus, oops, the color is not too good. Y equal to 12 minus 2 times x equal to 2, 2 times 2. So y equal to 12 minus 2 times 2, so negative 2 times positive, that's negative 4. That's 12 minus 4, right? So y equal to 8. Okay, now, next one. X equal to 3. So we have to change this to y equal to 12 minus 2 times x. So 12 minus 2 times, we change x to 3, right? 2 times 3 is 6. 12 minus 6 is 6. Okay, last one. X equal to 4. So the function is y equal to 12 minus 2x. So 12 minus 2 times what? 4. 4. 2 times 4, 8. 12 minus 8, 4. Okay, let's graph it. Let me erase everything. Okay, let's graph those 3 points. 2, 8. 2, x values start from x value 2 and then positive 8 right here, right? This point. Okay. This is the first point. Second point, 3, 6. Second point, 3, 6. So 3, 6. Yeah, this is 6. So the second point right here. Second point right here. Last point, 4, 4. So 4, 4, x value, y value, both 4. So the point is right here. Okay, 4, 4, right here. Done, 3 point. Okay, number 3. 3x minus 3y equal to 9. For domain, oh, look at the domain. This is another way to write out the interval function. That means x is greater or equal to 0 and less than 8. So this one I can also write like interval notation. So from 0 to 8, any value between 0 and 8. So this graph going to be line, yeah, continuous. So when x equal to 0, okay, what is the y value? So 3x minus 3y equal to 9. We need to solve for y, right? So negative 3y equal to 9. I'm going to move this positive 3x, move it away. Move to the other side, cross the equal sign. Move to the other side. It's going to be minus 3x. From positive to negative. Now, we want y. We don't want negative 3y. So we have to divide both sides by negative 3. When we divide, we divide every term. So negative 3 divided by negative 3, they cancel out. Become 1. Negative 3 divided by negative, that's 1, right? So 1y left. So 9 divided by negative 3 is negative 3. Oops. Negative 3x divided by negative, so negative 3. So negative divided by negative, that's positive. So positive. 3 divided by 3, that's 1. We don't need to write out 1, so x. So y equal to negative 3 plus x. Now, we need to figure out the y value according to the table, right? When x equal to 0, that means negative 3 plus 0. Still negative 3, right? Next one, when x equal to 3, so y equal to negative 3 plus 3. Negative 3 plus 3, that's 0. So this equal to 0. Last one, 8. So y equal to negative 3 plus 8. Negative 3 plus 8. So this is also equal to, I'm going to put the positive number first, right? So 8 minus 3, that's 5. That's 5. Okay, let's graph this. First point, 0, negative 3. So when x equal to 0, x equal to 0, y is negative 3, right here. X value is 0, the y value is negative 3. Second point, 3, 0. So this time is x is positive 3. Positive 3 right here. The y value is 0. That means this point is on the x-axis. So 3, 0 right here. Last one. 8, 5. 8, 5. 5 is right here. So this point, right? This is the 5. The y value is 5. This point is right here. 8, 5, right here. And then we are going to connect them. All right, this is the graph. We don't have any extension get out of both ends. No. Because the domain given is greater than 0 and less than 8. So it's only a segment part, right? Only one little part. Okay, number 4. The function h of d equal to 2d plus 43 relates the height of the water in the fountain in feet to the d diameter of the pipe carrying the water. Graph the function and use the function to find the height of the water when the pipe has a diameter of 1.5 inches. So that means the height of the water in a fountain. If you use a bigger pipe, the water flow going to be quicker, heavier, so the water going to rise up quicker. Right? So now we are already given the function h and d are. So the table has a little problem. The table uses x and y, right? So in fact, here should be d. So this should be d. This should be h of d. But either way, this x and y, same thing. Pretty much the same thing. Let me rewrite. It's d. Inside the parenthesis, always the same as x, right? And the y value is h of d. Okay, let's check when x equal to 0. That means when d equal to 0, this part is 0. 0 plus 4.3, 4.3. Okay, now when d is 1, so 2d plus 4.3. That means 2 times 1 plus 4.3. So this is 2 plus 4.3, that's 6.3. So 6.3. Next one, when d equal to 2. So that means 2 times 2 plus 4.3. 2 times 4, that's 4. 4 plus 4.3, that's 8.3. So 8.3. Table is done. Now we're going to plot the point on the graph. When x equal to 0, the y value is 4.3. 4.3. X equal to 0, 4.3. Something like this right here. X equal to 1, 6.3. 6.3 right here. When the x equal to 2, 8.3. 8.3 right here. Yeah. Graph the function. Okay. This is a continuous function. Remember the water, when we add water into something, the water cannot jump from 1 gallon to 2 gallons. It covers everything from 1 gallon to 2 gallon, right? From 0 to 1 gallon into 2. Solution. Okay, I already forgot the question. Okay, graph the function. Okay, we did already. Use the graph to find the height of the water when the pipe has a diameter of 1.5 inch. Okay, let's find the diameter. 1.5. 1.5 right here. 1.5. The height of the water is what? 7. Maybe 7 point what? Graph the function and use the graph to find the height. If we use the function to find out if we use the equation to find out the height, it's going to be more accurate. Use the function may not be very accurate because we have a guess, right? So let's do this. 1.5 is right here. Go up. Let's find the y value. The y value should be what? 7.3 maybe? Okay, 7.3. Approximation. 7.3 feet, right? 7.3 feet. Good enough. This is lesson 4.